Okay, today, review. So it's unit circle review, chapter 11, and let's take a look at how we do this stuff. So first of all, cosine's the x value, right? Everybody knows that. Of course you know that. Go to 5 pi 6, which is right there. The x value is negative square root of 3 over 2. That is the answer. Easy. Don't give me a decimal answer. I will count it wrong, okay? Secant. Secant is 1 over the x value. Okay, so let's see, 1 over the x. So I go to 5 pi thirds, which is here. 1 over the x value, which is 1 over 1/2. Okay, so we get 1 over 1/2. We talked about the other day, if you get 1 over a fraction, it just flips it, right? So we're going to flip it up to 2 over 1, which is 2. Right?
We just flip the fraction and then just cancel the 1.
Right, it just flips it over, right? So here's a rule. 1 over a over b becomes just b over a, always. And you know why? It's that whole divide, invert, and multiply thing, right? Fraction, you got 1 over 1, and then you invert and multiply, right? Does that make sense? Everything makes sense. Okay, negative 3 pi 4. So the thing is, negative 3 pi 4 3 pi 4 is here. It's a rotation. So negative 3 pi 4 rotate back the same amount to negative 3 pi 4 is right here. So if we need the sign at negative 3 pi 4, it's the y value. It's just going to be a negative square root of 2 over 2. Tangent of pi halves. Now we were nice enough that we put all the tangent values on the outside. Oh, I didn't put them on mine, but it's all good. They're on the board, right? So tangent of pi halves. Here's pi halves. Tangent is going to be the y over the x. That's not going to be good. Or if you look at on the circle on the board, it's the undefined one anyway. So this one's undefined, right? Because you've got 1 over 0, and you can't divide by 0, can you? It's going to make Cookie Monster very sad. Now, what's the difference between these first 4 and the second 4? Is this little inverse symbol, okay? So the inverse means find the angle. It means find the angle. And these pi 6, these symbols, these pi things are angles. These are angles. They just don't look like angles. But they really are the radian equivalent of the degrees. And of course, degrees are for dummies, so we're not going to use those. So, negative square root of 3 over 2. So for the y value, sign y value, right? We need a y value. A y value. So if we're looking for negative square root of 3 over 2, negative square root of 3 over 2 for the y value is here, or it's here. Okay, now we got to be careful. Which one's closer? So 5 pi thirds is closer if you go down to it, but it's much longer if you go all the way around to it, right? So we don't want to go all the way around to it, we go down to it. Now if you need to put these, in fact it might not be a bad idea right now, you can add these into your circle. Negative pi 6, right? Negative pi 4ths, negative pi thirds, and negative pi halves. So you have the negative angles on your circle, okay? So anyway, if I'm back to negative square root of 3 over 2, we're going to use the negative pi thirds because it is the closest to the origin. So how about negative pi thirds. There we go. Tangent is 0. So I'm looking for an inverse. I'm looking for the angle. So tangent is here on a unit circle. It's also way over here. Okay. Yeah, it's just 0. 0 radians is an answer, so I'm going to go 0 radians. Okay. Cosine inverse of negative 1/2. Okay, negative 1/2 is, for x is here and here. Okay, which one are we going to use? I'm going to use the 2 pi thirds, right? 2 pi thirds is closer. So I'm going to go 2 pi thirds is closer, okay? Tangent square root of 3. Oh, it's right there, isn't it? It's also down here, but which one's closer? Obviously that one, which is my pi thirds. Am I doing all right? I'm not going too fast? Okay. Pi thirds. Okay. All right. Sine inverse of negative 3. Impossible. Because if it's the furthest down for the y value goes negative 1, I can't go to negative 3. It's off the circle. You guys agree? It's off the circle, so this one's going to be really undefined or no solution, or what do you want to put? I'll put undefined. Impossible. No solution. Okay, number 10. Number 10 is a little bit different because it says find all angles. So, we're going to be able to take more than one answer, okay? So how does it work? We're going to go around the circle from 0 to pi. So I'm going to look for all of the answers from 0 to pi, okay? All of them. So I'm looking for negative 1/2. So let's check it out. So negative 1/2 for x, here's 1, 2 pi thirds. And here's the other, 4 pi thirds. So I want both answers. Do you see how the question says to find both? So the question says between 0 and 2 pi. So I'm going to get more than one answer. I'm going to get my 2 pi thirds, and I'm going to get my 4 pi thirds. I want both answers, okay? All right, 11. We're getting there. Given the tree graph, find the amplitude, period, vertical shift, horizontal shift, and equation. Okay, so first of all, amplitude. Let's see. Amplitude. We'll do this on the side. I know the amplitude is the max minus the min divided by 2. So my max is 4 minus a negative 1 over 2, right? Which is 5 over 2 or 2.5. So my amplitude is 2.5. Okay, there's my amplitude. Circle that. Okay, the period. Well, if I were to take a roller coaster ride, maybe I'd get on here, go up and down, and then that's one ride, and then I'd have to do it again and again and again. But one ride has a width of pi. So the period is pi, because that's the width of the curve, okay? Now the vertical shift. In this case, it sure looks like it got bumped up, because the middle of the curve, right? So if you can't quite figure out what the vertical shift is, there's a way. So the vertical shift, we call it K, is going to be the minimum plus the amplitude, okay? So that's the minimum plus the amplitude. So the minimum is negative 1. We already established that the amplitude was 2.5. So we get an answer of 1.5. And we're going to use that as we, okay, 1.5. Now, horizontal shift. Let's talk about this. Depends on what you want to call it. If you want to call it a sine, then you'd have a horizontal shift of pi fourths. If you want to call it a cosine, you'd have a horizontal shift of pi halves. If I call it a negative cosine, then there's no horizontal shift. Does that make sense? Depends on where you want to start. Do you want to start in the middle of the curve? Call it a sine. Top of the curve, call it a cosine. Or down here, I like to start down here because we're right on the y-axis. So I'm going to say there's no horizontal shift. So I'm going to say none because I want to call it a negative cosine. So equation, I like this as a negative cosine. So I'm going to start off with a y equals, I know the amplitude. I'm going to go negative 2.5 cosine, and it's going to be cosine of my my b, and to find b, I haven't done b yet. B is going to be my frequency, which is 2 pi divided by my period. Okay, b, which is the frequency, is 2 pi, always 2 pi divided by what the curve width is, which is pi, which is going to be 2, right? X, I'm not going to do a horizontal shift, so there's nothing inside there. Because I'm going to start here at a negative cosine. And then it got bumped up 1.5. That's my vertical shift plus 1.5. Okay, again, just to repeat myself, there are 4 different possibilities. There really are. There's a cosine and a negative cosine. There's a sine, there's a negative sine. It just depends on which one. I thought the negative cosine was the easiest one to use. Do you have to use mine? No. Just one of the 4, as long as it's correct, okay? All right, yes?
Why is the 2 before the x?
Well, you could write it as 2x, but normally it is, Will. Normally it is. If there's a shift inside, I like the 2 on the outside, okay? Okay. You could, in this case, write as a cosine of 2x. Same answer, okay? Do you like that better? Same answer.
Where's the 2 coming?
Yeah, what does the 2x mean?
The 2 means, you ready? The 2 is frequency. It means that there are 2 curves within 2 pi. That's what it means. And there are 2 curves in 2 pi. So it's called the frequency. How many curves, right? Frequency, right? And there's 2.
Do you use 2 pi for every single?
Almost. Great question. And how do we know? We go to this, right? Period, 2 pi. Period, 2 pi. See? Tangent's different, right? 2 pi, cotangent's different. So great. So if you have this, these are the normal periods, right? And these are the ones you divide this number by whatever is sitting right there, okay? Okay. 12. All right, now this one's the one that's going to give us a little trouble. We can do it, okay? Given the equation, a negative 4 secant of 3x minus 1, where are the vertical asymptotes? So we want to graph this, okay? Where are the vertical asymptotes? Let's graph this one. So, piece of graph paper. Okay, let's see if we can do this. So, when I do these, again, the first thing I do, very first thing is let's look at the graph. Let's see what it looks like. So, if I'm going to go to secant, and secant looks like this, okay? That's my secant. Yeah, I found some new graph paper, Ash. Nice, huh? So secant looks like this, but I've got my little thing about cosine. So what I want to do is first graph in a cosine. So I know what it looks like. I know I want to graph cosine first. So before I do anything, I'm going to say, okay, I want to really graph first. Let's graph a y equals a negative 4 cosine of 3x, okay, minus 1. Okay, let's graph that first, all right? So to do that, then I'm going to go ahead and put my axes down. You guys see this? Yeah, we can. Okay. This is the hard one. This is the hardest one on the test, but we can do it. Have faith in us. Okay. There we go. Now, first thing, I look at the shape of the graph. Looks like this. Second thing, I need to know how wide the curve is. Pi halves, pi, 3 pi halves, 2 pi, no, not this time, no. I'm going to go in terms of thirds. I'm going to go in terms of thirds. How do I know I'm going to go in terms of thirds? Because I need 3 curves, you ready? Here's what it means. Remember frequency? I need 3 curves in 2 pi. If I need 3 curves in 2 pi, I got to divide it into thirds, right? So let's do that. So let's take my 2 pi and divide it into thirds. Well, I can't really divide that evenly, so I know that I'm going by thirds. So when I make my little axes, let's go every 4 squares, pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds, 5 pi thirds. I'm running off my paper, so I'll just stop there. And negative pi thirds, okay? I know my amplitude's got to be from 4 to negative 4, 4 to negative 4, okay? All right? And then when I do it, I like to put a little drawing on the side of like the kind of the shape, so then I can fit it in better. So I'm doing a cosine. It's got to be a negative cosine. So look at my cosine. So it's this shape. It's this shape for cosine, right? But it's got to be upside down. So it's this shape for cosine, but it's going to be upside down. So just off to the side, make myself a little drawing here. Negative cosine looks something like this, okay? So I took my cosine. Here's my shape. And I made it upside down, okay? Now, I'm going to go from 0 to 2 pi thirds, okay? So, you ready? I'm going to take this shape right here and put it on my graph. Well, that's not too hard. So, I'm just going to go here, 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 okay? Lightly sketch it in. Okay? So, there it is. Same shape from negative 4 to positive 4. And I got one full curve in 2 pi thirds, right? And I can do another, right? Let's just do another here, 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 there. Okay, and you know, whatever, get another one in there, whatever, right? Come back and do another this way. Okay, how am I doing? Now, there's one more thing I got to do is take this whole thing down 1. Okay, I want to graph the whole cosine. I'm not going to do a secant yet, but I have to do the whole cosine. So I move every important down 1. Okay, so the whole thing is going to shift down 1. That's easy, right? That's down. Okay, so you shift the whole thing down 1. Actually, do I need to put my asymptotes in first? Yeah, I got to actually put my asymptotes because I'll shift this one. Let's not shift it until the end because we're going to do this one. Okay, so where do the asymptotes go? Yeah, there, 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 and there, okay? So let's put my asymptotes in there. The x-axis is totally right. There, 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 and there, okay? Now my loops, I'm getting close to my answer. My loops would go, my loops on top of the curves, but we're going to take the loops down 1. Okay, does that make sense? So I'm going to do one last thing before I graph it. Let's take the whole thing down 1 curve. So that means, as an answer, okay, I'm getting there. see if I've got a good color in here. All right. As an answer, here's one answer. Down one. Another answer. Down one. There's an answer. Down one. There's an answer. Down one. There's an answer. Okay. Now, here's where kids make a mistake, but you're not going to make a mistake because I'm also asking where are the asymptotes. Well, the asymptotes are, okay, you can do fractions. I know you can. If that's pi thirds, that's pi 6, right? If that's pi thirds, isn't that pi 6? So that'd be pi 6. So 1, 6, 2, 6, 3, 6, 3, 6. Oh, that's like 1/2, isn't it? Oh, yeah. 3, 6, 4, 6, 5 pi 6, right? 5, 6, 6, 7 pi 6. So, and it's a negative pi 6. So I'd answer for my asymptotes, you ready? I would answer for my asymptotes, slide this up, where the asymptotes at. I'd say my asymptotes are at negative pi 6, at pi 6. At 3 pi 6, how about pi halves, right? Same thing. At 5 pi 6, 7 pi 6, and that's enough that you put those down. I'm pretty guaranteed you know what you're doing, right? I know you can do this tomorrow. I have faith in you. Okay? That is probably the hardest question on the test. Is that comforting to know?
No.
Well, the first 8 were easy. First 9. First 10. First 10 were easy, right?
Yes.
First 10 was easy. Bam, right? So we can do those. Okay, tell me when you're ready for me to turn it. Okay. Oh, yeah, that's not supposed to be there. Never mind. That's not there. I'm reusing graph paper. I'm just recycling. It was question 13 from like class before. Okay, yeah. Okay, you guys ready? All right, now. 13. It's a cotangent. All right. Gosh almighty. Same thing. How am I going to do a cotangent? Well, step 1. What the heck does a cotangent look like? Looks like that, right? So I use my graph. Cotangent looks like that. So I'm just going to kind of draw a little something on the side. Cotangent looks like this. And cotangent has asymptotes here and here. That's what my cotangent curve looks like, okay? So now, what do I want to do? I want this shape, but I'll make it upside down, right? So this thing's got to be upside down. So hold on, erase for a second, because I want to make it upside down, right? Let's see if I have an eraser. You never know. Wouldn't that be a miracle? I do. So let's make it upside down, right? So now, if I make cotangent upside down, it looks like a tangent curve, doesn't it? Right? Huh? Now, this point right here is going to be at a height of 2, and this point right here is going to be height at negative 2, okay? It's a tiny thing, but, okay, because of the 2, okay? Now, that's my cotangent curve, and the only thing I'm going to do with this cotangent curve is I'm going to move it pi 8 that way, okay? Because it's got to go the opposite direction. So if I have to move it pi 8, I've got to make sure that my axes have pi 8s in, okay?
Why are you going backwards?
Great question. Always the opposite inside. Remember that? Always, okay? And the reason why is because a positive pi 8 would zero it out. That's why we do the opposite, okay? All right, so let's see if I can do that. Okay, so I'm going to go ahead. I know I want to put really on the side. I want this kind of shape here. I know I've got to have boom, 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 boom. And I know it's got to look something like this because, oh, sorry, Marie. It's got to look something like this. So here's the basic shape, right? It's upside down. So let me do that. So there is absolutely no change in the period. There's no number here. There's no number there at all. So the period, the width, did not change. So 0 to pi is going to stay 0 to pi, okay? So let's go pi halves, pi, 1, 2, 3, 4, 3 pi halves, 1, 2, 3, 4, 2 pi. Get that in, get that in. Got to have a 2 and a negative 2. So we have a 2 and a negative 2, okay. So I'm going to do it in pencil because I want to move it, right? So in pencil I'll put my little dash, 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 and so it's going to look something like this. Okay, it's going to look like that. And I'll stop and let you look at it for a second, okay? Okay. This is exactly what my main sheet says, except it's upside down, okay? All I'm going to do next is just move it, okay? I'm going to bump it. I'm going to bump it pi 8ths that way, right? Pi 8ths 1. And pi 8ths is 1 square, isn't it? Because if that's pi 4ths, that's pi 8ths, right? Pi 4ths, pi 8ths, right? So just take everything. So I'm going to move my asymptote over. I'm going to move this asymptote over. I'm going to move this asymptote over, okay? Then I'm going to take the whole curve and bump it over. Okay, so I'm going to take the curve, I'm going to bump it over. Okay, so it's going to go here. I'm going to bump it over. Pi 8ths, which is a square. Pi 8ths, pi 8ths. There it is. Now, what's the phase shift? Phase shift is a horizontal shift. What's the horizontal shift? What's the phase shift? That's the horizontal shift. You just shifted it. How much did you shift it?
Pi 8.
Yeah, so your phase shift is pi 8ths. That's your phase shift. It's pi 8ths. Good. Where are the vertical asymptotes? Pi 8ths. It's 1/8, 2/8, 3/8, 4/8, 5, 6, 7, 8, 9 pi 8ths, right? 9 pi 8ths and pi 8ths. So my asymptotes are at pi 8ths and 9 pi 8ths. Okay? It smells like bacon. Yeah. You know, I haven't had bacon in 10 years.
10 years?
Yeah, I don't eat bacon. Yeah, isn't that crazy?
I have bacon.
It's like same thing with butter. Oh man. Okay.
You haven't eaten butter in 10 years.
Oh, every now and then I'll get a taste of butter and something. I'll go, ooh, yeah, that's yummy. Yeah. Okay, you guys ready for the tide problem? We know how to do the tide problem. We do. Okay, let's see if we can check this tide problem. Okay, so when I do my tide problem, first thing I'm going to do is I need a 24-hour axis, right? So I'm going to do a 24-hour axis. So I'm going to go ahead and start way back here at midnight, and I'm going to go all the way. So I know I'm doing a 24-hour clock, right? So let's start right off the bat with midnight. And let's go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's 12. 1, 2, 3, 4, 5, 6. 18 or 6, right? 1, 2, 3, 4, 5, 6, which is 24 or midnight again, right? All right, you guys okay? I put in the PMs, but it's better to do it in a 24-hour clock, right? So I'm going to do that first, and then I know I'm going to have a high tide of 5, low tide of -2. So 1, 2, 3, 4, 5, and 1, 2, -2. Okay, I'm going to need those for sure, okay? So the height of tide was 5 meters at 1 o'clock a.m. So let's go 1 o'clock there, okay? And the low tide was 8:45, which is about there at -2, okay? Now, the very first thing I want to do is what is the time for that half tide? This is the way I do it. So the half tide is going to really be my 8:45 minus my 1 o'clock, right? From here to here, right? Which is 7. So my half tide is 7:45. So the tide goes from high tide to low tide in 7 hours and 45 minutes. Does that make sense? High tide to low tide in 7 hours and 45 minutes, okay? So then what's a full tide? So then it's a full tide.
So you just always take the bigger number and you subtract the smaller.
Yep, it's that easy, yeah. So the full tide's got to be 2 of these, 7:45 plus 7:45, right? Which makes a 14 and 1/2 or a 15 and a half. You okay with 15:30? You get the 14, right? And then 45 and 45 makes an hour and a half, right? Everybody agree with that? Okay. It's handy to change it into decimals, right? Because when we start working with pi, let's change this into a decimal. So as a decimal, this is going to be a 15.5, okay? That's your period, okay? Does that make sense? That's your period. That's your period, because the period is the width of the tide. So, the next thing I can do is figure out what my next high tide is, right? So my next high tide goes... What's that? Yeah, I sure can slow down, okay? Absolutely. Yeah, so 15:30 is the length, so it's 15 hours and 30 minutes is from high tide to high tide. 15 hours and 30 minutes from high tide to high tide, okay? But I changed it to a decimal because 15:30 is the same as 15.5, like half an hour, right? Okay. So the period, I've got it. I already got it. Period in hours and minutes. That's going to be 15 hours and 30 minutes. Got that, okay? Boom. Does that make sense? Like Elijah said, just subtract the biggest from the smallest, and that gives you the half tide, and double it, right? Biggest minus smallest, biggest time minus smallest time gives you the half tide, high to low, and then double it so you go high to high. Gerardo, how am I doing? Good. Okay, now, what's the height at noon? I'm going to have to guess at that. I don't know quite know, but let's do D first. When's the next high tide? Let's do this one first, okay? So, to do D, the next high tide is going to go from this little spot right here at 8:45, and I'm going to add in my half tide. What's my half tide? 7:45, right? Okay, so it's going to be a 16:30, right? 8 and 5 is 15, and 45 and 45 makes an hour and a half. You okay with that? So that would be 4:30 p.m. Wouldn't that be 4:30 p.m.? Or you could go 16:30 military time. I'd take it. Okay, great, no problem. I can handle military time. Or we could say next high tide is 16:30 military time, or we can call that 4:30 p.m. Right? So all I did was I took my low tide and I added in the length of my half tide. Okay? Took my low tide time and added in the time of a half tide. Okay? Now let's try and see if we can get an equation, because we're going to come back to B when we're done. Okay? So an equation. All right. So if I put my 4, let's see, 1, 2, 3, 4, 30 here. Okay. So I can sketch it. It doesn't have to be perfect, but if I try and sketch it in. All right. Okay. What's that? Great. I want you to ask Landra. Yes. Yeah. Now, let's get an equation. So my equation, first of all, I'm going to call it a cosine because I can find the top of the curve, okay? I like to call it a cosine. It's easy to find the top of the curve, okay, the max. So let's start off y equals. Now, what's the